So my name is Amir, and today's presentation is about 3D simulation models for developing the digital twins of heritage structures. Um, I'm working on in a Hyperion project. Hyperion project is a European Union funded project, which is a part of Horizon 2020. And the main aim of this, the main goal of this project is to improve the sustainability and resiliency of the historic areas. The historical structures are so important and for the nations and for the societies, and can be can be a good attraction for the tourism. Also, there are several institutions around Europe that they are working in different work packages, in 9 work packages to investigate. And we are as a work package 5. Our goal is to investigate the structural vulnerability of the historical structures and the historic areas. For developing the digital twins of the historical structures or different full-scale structures, 3D geometric or geometric documentation and geometrical survey is very important. And for the Hyperion project, we are working on 4 case studies in 4 cities: Granada in Spain, Venice in Italy, Tonsberg in Norway, and Rhodes in Greece. And for the initial 3D modeling and representation of cultural heritage assets, the combination of geodetic, photogrammetric, and laser scanning data acquisition were carried out. And in this slide, you can see the picture and images of the case studies in Rhodes in Greece. For the digital images, the digital images were processed at first in a IBM software, and the dense point cloud are the product of this procedure. And the dense point cloud, the point clouds were processed, and the point clouds will be registered with the scanned point clouds from the 3D laser scanners to fill the eventual gaps in the scans. And after that, the 3D point clouds, which is dense, will be translated to the final 3D mesh. As you can see in the table, there are 4 case studies: St. Nicholas Fort, Nilock Tower, Roman Bridge, and Rodini Tomb, that they are the number of the aerial images that they were taken from the drones, and the ground images that they were taken from the cameras. And these both images are considered as digital images. And after that, there are some scans from the 3D laser scanners that are provided for these 4 case studies. And the product of this 3D geometric documentation is the 3D texture models that you can see in the top right of the this slide, that can be utilized to see the texture of the masonry, and also the light 3D models and cross sections that can be provided and for after the procedure for the procedure of the 3D geometric documentation. And these products can be utilized by the structural engineers to develop the finite element models and numerical models of the structures, and the orthomosaics and DSMs that can be utilized for investigating the loss of material of these historical structures. 2 case studies are investigated, and the procedure of translation of these structures, these full-scale structures from full-scale structures to the finite element models have been discussed in this presentation. The Roman bridge is a stone masonry bridge in Rhodes that the finite element model was developed based on a traditional way, that the measurements and distances were taken from the 3D geometric documentation, and the finite element model was developed in a finite element software packages in a Diana software package. That you can see the finite element model of the Roman bridge in this slide, that it's composed of several parts: the backfill soil, parapets, spandrel wall, and the arches, and also interface elements are utilized to model and simulate the interaction between the backfill soil and the masonry part, which is the spandrel wall and the arch. And in the bottom of this slide, you can see the finite element mesh of this bridge, which is ready to do several kinds of finite element analysis. As the second case study, the 3D finite element model of the Slottsfjell Tower, which is a stone masonry tower in Tonsberg in Norway, is developed in a semi-automatic way. At first, the 3D laser scanning was done, and after that, the 3D laser scanning product, which is the point cloud, was imported to the Recap Pro software to provide the 3D point clouds. And after that, it's imported to the Revit software to provide the 3D models in a versatile software package, which is a Autodesk software package. And after that, it's imported to the Diana software, which is a finite element software package. And finally, the 3D finite element mesh of this tower is provided. As you can see in this slide, it's a tower, and the whole procedure is provided in this slide. At first, it's you can see the real structure and the 3D point clouds, the 3D point cloud in the Recap software package, and after that, you can see the 3D point cloud in the Revit software package. The 3D model is provided in this software package, and after the step file format of this structure is imported to Diana, and by using some optimization tools and for minimizing the imperfections of the 3D models, the final finite elements model is provided, and the meshing was done in the Diana software package to provide the 3D finite element mesh of this historical stone masonry tower in Tonsberg. There are some future plans for these case studies and other case studies in roads. At first, we would like to do the operational model analysis using the accelerometers for the Slottsfjell Tower. The operational model analysis was done, and after that, the finite element model updating should be done to provide the calibrated finite element model. And after providing the calibrated finite element model, the seismic vulnerability assessment should be done, for example, on the Roman bridge, which is susceptible to the seismic excitations, and it's located in a high seismicity zone in Greece, using different methods of analysis and nonlinear analysis. And after that, the effect of soil structure interaction on this bridge, and also the effect of soil structure interaction on the finite element modeling procedure of the Tonsberg Tower should be done in future. Okay, thank you so much for your time and consideration.